Yeah, so you can ask questions on chat, but unfortunately, I won't be able to monitor the chat. Maybe you can add questions like coordinators from each university. Please help me to collect those chat messages from the chat window and let me know if there is any question that I need to address. And I ask only coordinators from the respective university. You can arrange yourself in a way that you can help this process, because there are more than 150 people attending this training, and I may not be able to read the chat at the same time do the presentation. So again, thank you so much for joining me on this exciting journey. So this is the foundation of machine learning. I know some of you might have already attended this portion of the training, but I have to repeat it because most people were affected last time. So I have to start over, and just it won't hurt for those of you who have already attended this portion of the training. So for those of you who haven't, who don't know who I am, my name is Daneko Jambari, and my email address is this one. So you can utilize my email address. And if you use this email address, since I use this email address for multiple communications from different with different universities, I want your communication. I have a rule that I set up to put all your emails into a folder, and you should include FML with this bracket, like just with this bracket in all your email subjects. Then I will know that those messages are from this training group. And regarding my current engagement, I'm a principal software engineer and data scientist at Microsoft, and a part-time instructor for big data analytics and ML courses in University of Washington. And as we are doing right now, I remotely teach and advise for postgraduates, ML and data science students at different universities in Ethiopia. So now this is part of the service that I'm offering. This service is for free. And if you are inspired by this, do the same for your people, your country, and at times just your neighbors. It won't hurt. So that's just a way that you can pay it forward. And my education, as you have already seen, I have a PhD in data science specialization and Masters of Science from Maharishi International University, an MSc from Addis Ababa University School of Information Studies for Africa. Now I think it's called School of Informatics, and bachelor's degree from Kotabe Metropolitan University. I think by now its name got changed. In any case, so this is my academic qualification and background. As of 2009, February, I have been working at Microsoft as a software engineer and data scientist, building applications in machine learning models for enterprise-grade applications. And before that, between 2006 and 2009, I was a developer I worked as a developer at multiple companies, including companies that focus on gaming, manufacturing, and etc. And between 1997 and 2004, I was teaching in Ethiopia and serving as an instructor for database management system, statistics, and mathematics courses at private and public universities at Addis Ababa, Ethiopia. Nathaniel, do you have a question? Nathaniel Goshu. Okay. Anyways, so this is who I am. Next. So since the focus of this course is about machine learning, we need to first define what machine learning is. As per the academic definition, machine learning is a computer program. Well, to define it, we address it in the following way. You have experience, task, and measure. And a computer program is said to learn from experience with respect to some class of tasks T and performance measure P if the performance at tasks in T as measured by P improves with experience. So whatever we say here, experience means historical data. And task means the thing that we want to train the computer to learn from, to learn about. To learn from experience, to learn about a specific task, and we measure this learning from experience using a matrix P. And then if we can improve that measure, that P or the matrix, that means we are training the computer to learn from experience about a specific task. This is what machine learning is. And programming computers to optimize a performance criterion using example data or past experience is also machine learning. So we're basically just programming computers. We don't explicitly program a computer, but we enable the computer to use a certain data to understand and learn from the given historical pattern and help us to predict or infer about that particular task on unseen data. So this is what the general definition of machine learning. As we go along, the recent quotes related to machine learning are Bill Gates, who is the co-founder of Microsoft, said a breakthrough in machine learning would be worth 10 Microsofts. Currently, Microsoft is a $2 trillion dollar company, the market cap, like just more than 2 trillion. And it is the second big company in the world. The first is Apple, which is more than close to 3 trillion. So when you see that, what Bill Gates said is probably like just about a 20 trillion company, which is 10 times Microsoft. So as we see, it is happening because of the impact that machine learning is creating today, especially the positive one. We have yet to, there are negative impacts as well, but yes, it is true. Machine learning is a breakthrough. It basically have an impact to create, to have 10 Microsoft impact on the world. And the reason why Bill Gates mentioned Microsoft the way it is the first vision of Microsoft was to put a desktop on every desk in the world. And I believe that has happened. Even if people don't have computers, they have cell phones. It happened. Those cell phones are now as big as the early computers, right? So the impact of machine learning is tenfold of that. And machine learning is the next internet, Tony Feather said. And again, just you can see the different quotes about machine learning, multiple things. And just this is how these quotes are for you to sense the impact of machine learning in development. And the taxonomy of machine learning looks as follows. We have machine learning here at the center, and artificial intelligence, deep learning, big data, data analytics, and data science, and they share a certain intersection. So if you put them together, artificial intelligence is the biggest field. Machine learning is at the center of artificial intelligence. Deep learning is at the center. If you see those three, they are you can consider them as concentric circles. Although we moved the center of each so that we can have their labels, but deep learning is as the center of machine learning. Machine learning is as the center of artificial intelligence. And big data exists in most of these technologies. And data analytics has got something to share from data science and big data. So we have this taxonomy, and the definition, you can read through the definitions, but artificial intelligence is a way of performing tasks and iteratively improving the program that we want a machine to learn from, based on an information or data collected. And data science is an interdisciplinary field that uses scientific methods and processes as well as algorithms and systems to extract knowledge and insights from data. As you can see, data science, has intersection with artificial intelligence, machine learning, and deep learning. So because of its usage for different algorithms to extract insights, yes, it is related to all these fields. At the same time, at the center of data science, we have big data, because when we want to extract insight from data, we need big data. We don't basically choose a specific type of data to extract insight. By what that means is big data has got its own characteristics that distinguish it from other types of data. Big data has got a volume, a variety, and a huge velocity of the generation. But some data may not have these characteristics. As a result of that, for other data types, we can also apply data science. And here we also have data analytics. Now, why is data important? So why data is important for science? As you can see, the artificial intelligence is the most preferred area for people to learn, because based on just the hiring trend, it has 74% hiring growth over the past 4 years. On the other hand, other roles such as data science and robotics engineers are growing so quickly. You can see the details. And data science is also one of the most sought after career. In relation to that, there is a 37% growth over the past 3 years. These are reported by LinkedIn and then just the ZDNet. When we come to machine learning, traditional programming, we have to distinguish between traditional programming and machine learning. Traditional programming is coding and creating a program. The output of a traditional programming, is an output for which you provide data and the program. So in a traditional programming, you write the program and you provide that data to the program, or you deploy the program on your computer, you provide the data, and then just you get the output. On the other hand, the machine learning approach is you have experience, rich experience in data, and also you have an output that you know about that particular data, and you combine those two on a computer, educate or train the computer so that you get the final output as a program, a computer program. That program is called the machine learning model. The machine learning model is the output of data, the output of the training process on a computer using the data and the corresponding output of that particular data. Here are some of the most common, the word cloud of some of the most common used terms in relation to machine learning, data mining, knowledge discovery, machine learning, algorithms, methods, examples. All these are different terms, or this is a word cloud where you can just relate to machine learning, like data mining, knowledge discovery, statistical learning, pattern recognition, computational learning, and predictive analytics. So these are in a way related to machine learning terms. So just now, let's see machine learning by example. Some of you might have already know what machine learning can do for us, but one particular example of machine learning is classification. Just all of us here in this training use emails. If it wasn't through email, we wouldn't have communicated. So when we use email, a spam filter is one of the capabilities that most email service providers provide to us. And in those spam filters, nobody is sitting there and just checking whether or not an email that's sent to you is either just a legitimate email or a spam email. So computer gets trained on historical data on such inputs as email subject, email body, the length of the message, the sender email domain, and the number of recipients. Based on these criteria, machine learning, just a machine can be trained to have a model, a machine learning model that we call a spam filter. Now, here, what you see at the center is a model that we call a spam filter, just checking each of the emails and then classifying them as either non-spam or spam. So this is just one particular example of machine learning, which is classification. As you can see, the input is here, the email subject, the email body, the links, the sender email domain, and the number of recipients. This, we could have like thousands of records about such details, thousands of email metadata, having these values. And then using this data, we train a computer, use a classification algorithm, and generate an output. That generated output would be a classification model. And when we use the classification model on emails, we would get a spam versus not spam output. Then just we take the next action. So the program will take the next action that you would need to be done on the particular object. Next, so another classification is from data to discrete classes. As you can see here, this is a weather prediction. In a weather prediction, usually you would get number, right? Numbers. Those numbers would be whether or not the temperature is higher, whether or not there is a certain drop of rain, whether or not there is rain, or depending upon different climatic metrics, you can generate numbers. And combining those numbers, you would say, oh, okay, today or on this day it's going to sunny, or it's going to be cloudy, or it's going to be rainy. And you can even associate a certain number, the numbers that you predicted for these specific scenarios. Or there could be like snows, or depending upon the number. But the input would be the quantitative data about the current state of the atmosphere or the land and ocean, and using meteorology to project how the atmosphere will change at a given place. Is there a question? Zacharias?
Yes.
Okay, Zacharias Darrab, your hand is raised. I will consider that as on accident. Okay. So the next example is machine learning model that can be used. Okay, so another example is a regression model for predicting a numerical value, and such model can be used in stock market. And the input would be historical price movements, market signals, mergers, acquisitions, financial earning reports, and etc. This is the most common data sought in the stock market. Is there any? We capture different types of market signals, right? How much is being sold? How much is being? How much is the sale, right? And whether or not there is like just a mergers of companies, and just depending upon the type of companies that are getting merged and their relationship with the target stock market symbol. If we are watching the Microsoft's stock market, then just we would collect Microsoft related information on the web or from the news, and based on that data, we would train a regression model that determines the price of the stock, and then say, just would use for making the right decision, either just I noticed there was some glitch. And now another example is clustering, which is grouping similar things together. And just this is one of the algorithms, the unsupervised algorithms that group similar objects together. So you can see like the colors are the groupings, right? You have these colors that distinguish between different groups. And let's say just the input data is life expectancy at birth, and the gross income mortality under 5 years, and expected years of schooling, etc. Using this input data, we could create a cluster of 3 groups, and these 3 groups can be seen as developed, developing, underdeveloped. So these are like how we could classify countries based on the details that we see here, and say, so these are countries which can be grouped together. We don't, we simply, we use data, and then based on that data, we group countries. We create a clustering model that groups countries. And another is embedding and dimensionality reduction. Sometimes the data that we see may be very difficult to see, understand, to grasp by simply looking at it, especially when it becomes multi-dimensional, more than a 3-dimensional data set. When that is the case, then we may convert the data to a lower dimension, such as converting words into vectors or converting images to vectors, so that we can see the dimension in a reduced dimension. Words, thousands of words could be converted to vectors, and how like just images with multiple colors could be converted to vectors, or multiple channels could be converted to vectors. And the input could be a high dimensional data in document or image or video, etc. Then once it is reduced, the output would be simple data with few attributes without losing the original context of it. So here we have like words converted to vectors. Here we have image converted to vectors. In any case, for visualizing the data, we convert a high dimensional data into a low dimensional data, most of the time like just in a 2-dimension or a 3-dimension. And we will see some examples in this area. And there are different applications of machine learning in science, environment, retail, for in manufacturing, in security, marketing, management, finance, and web. Just to mention, for example, in relation to application to our country, Ethiopia, we could use machine learning models trained for intelligent fraud detection in our financial institutions. And most recently, we have seen people tampering with financial transactions of individuals, and then especially like just employees. And we could create models that track similar kind of activities and identify who is doing what and in what kind of pattern. And the fraud detection is an important approach to protect the financial well-being of industries, companies, and also individuals, because to gain trust from customers, financial institutions should build such capabilities of protecting the people. So that's one particular example, and just we can apply security related machine learning models. And in this case, fraud detection or anomaly detection is one of the popular applications in different scenarios. And in case of marketing, for example, clustering is another good example here. For promotion, you can group different customers into different types of a company's customers can be grouped into different clusters or can be grouped into identified clusters, so that one, you can provide a specified service for those grouped similar customers, or do discount for those customers that are not frequently coming in buying items from you. Credit scoring and risk analysis are also again other applications of machine learning. And even in healthcare, machine learning application is important. Before the worst thing happens to a patient, you can have a model to predict about just based on different information on the patient. Then just a machine learning model can predict what's going to happen, but the model has to be trained on a similar scenario across multiple, using data from multiple patients over the years. Now, the overview of machine learning. This is like just one of the cheat sheets of machine learning and dividing a machine learning. So we will see a deeper dive of each of the machine learning approach. So today, machine learning, there are 3 types of machine learning. One is unsupervised, the other is supervised, and the third one is reinforcement learning. And each of these models have got their own application. For example, in unsupervised learning, we said that there is a dimensionality reduction, which means reducing the dimension of data to a lower dimension without losing the context. This application, these kind of models can be applied on big data visualization, on meaningful comparison, and structure discovery, and feature elicitation or feature extraction. And the other unsupervised learning approach is clustering, and clustering can be applied for recommender systems, such as like when you search on a shopping site, you would see, oh, you can buy this, and then also people who bought these also bought these other items. So this kind of recommendations improve sales for a particular site. So this is a recommendation. Or you may be searching for books, and you may not have enough insight about just the type of book that you're searching for. If you don't know the specific item that you want to buy, recommender systems will tell you, oh, you're looking for this book, but people who searched for this book also bought this book. So this is a kind of recommendation that you can have. So models that are trained for recommendations are used in recommender systems. And targeted marketing, which we mentioned earlier, clustering and customer segmentation, also segmenting customer either for providing some discounts or sending an email to encourage them buying what they used to buy. So depending upon your target, you can segment customers for different purposes. So clustering has got these different applications. And you see the other applications in case of classification, identifying fraud, image classification, or customer retention. So these are the way that you would classify your customers, that you would use classification models for diagnostics. And in case of supervised learning, just other types of the other supervised learning is regression. Regression is mostly used for forecasting and for prediction, depending upon the type of environment, type of domain that you're planning to use the technology. You can utilize any of these machine learning models. In any case, to summarize this slide, we have three types of machine learning approach: the unsupervised learning, the supervised learning, and the reinforcement learning. But what is unsupervised learning? What is supervised learning? And what is reinforcement learning? We will learn more about that in detail in subsequent weeks. And the different types of algorithms that we saw, we will see how we can build, how we can create machine learning models that would do most of the things that we said machine learning, whether unsupervised or supervised machine learning, would do for us. The objective of machine learning is, using the cheapest and abundant data and generating the most expensive resource, which is knowledge. So that's what the ultimate objective. And this is the pyramid of wisdom. So the ultimate objective of machine learning is ensuring that data can be, although cheap, can be used to extract insights, useful insights, and finally just enable or add additional additional intelligence to applications and services that we use in one or more scenarios. So this is the ultimate objective. So when is machine learning used? That's it. So this is a question that we would need to answer. Machine learning is not going to be always used. There are scenarios where machine learning can be used, and there are scenarios machine learning cannot be used. Among the scenarios where machine learning can be used are situations where human expertise doesn't exist. For example, you cannot send people to navigate Mars, so you would have to use robots to do navigation on Mars. So you would need this kind of intelligence. So that intelligence can be trained using data, and you can create artificial intelligence based robots, and the underlying model is a machine learning model that drives the mechanics of the robots. And humans, when humans are unable to explain their expertise, for example, in speech recognition and in vision, it's very difficult to, because this is the most complex area. And then just in that case, you would use machine learning models. And for example, solutions, if solutions need to be adapted or customized to particular cases for biometrics, for personalized recommendations. I mentioned this during our last, in first class, which I'm repeating again. Personalized recommendations, you can say you can recommend people, even your friends. But if you have so many thousands of people coming into your shop, which is impossible. So when I say shop, not a physical shop, but just a website, like just an online shop, it's very difficult to provide recommendation for everyone. Humanly difficult, humanly impossible. So what you should be doing is training models and watching what these people are trying to window shop, and then based on their window shopping, you encourage or you provide them recommendation. So the people's ability, you cannot utilize people, but you can utilize machine learning models to provide personalized recommendations. And models are based on huge amounts of data. And in case of genomics, it's because of machine learning that the health in the healthcare or in the field of medicine, like most things are getting just revealed now. There are so many breakthroughs in the most recent years because of the advent of computer science, and also just the advent of machine learning. So these are where machine learning can be used. But when is machine learning is not needed? Right? We have to stop trying to create models for everything, because when simpler alternatives are already exist that are equally effective, you shouldn't have to, because you wanted to use, you shouldn't use a machine learning model, right? Because you can create a machine learning model, you shouldn't create. You have to see whether or not there is an alternative solution, or a simpler and alternative solution, because machine learning model, creating a machine learning model has got its own cost. Maintaining the model has got cost. But if you have a simpler alternative that you can use, avoid the use of machine learning model. And when the relationship between all system variables is completely understood. So usually machine learning model is very effective when things are complex, especially when you are not able to explain. For example, vision, speech recognition, right? Or classification of images, when you have to do like thousands of attributes to be understood, and then just make classifying a particular image with those many attributes to a certain type. So when that's the case, you use machine learning model. But when you have everything well understood, simple, then just you shouldn't use a machine learning model. And the other one is if interpretability of results is not possible. Most of the time, like just unsupervised machine learning approach suffer from explainability and interpretability. So we shouldn't always have to just utilize machine learning models if we cannot properly interpret how we created the models, how we could use the models. And if there is a high error susceptibility, or if the model is a very poor performing model, there is no reason of using a machine learning model in that scenario. If you have a very limited training data and the bias, the variance of the model, and is so worse with the model is overfitting or learning more about the training data, not about properly predicting on testing data, that's a very good indication that you shouldn't be using a model, or you have to rethink about just what you're doing. So machine learning is incredibly powerful and can have significant or unintended negative consequences on society through targeting, excluding, and misusing. When this is the scenario, stop using machine learning. Stop using machine learning. Mainly, like the last point, has been an important issue, and there are even laws that are being discussed to create responsible AI or responsible ML, responsible machine learning or responsible artificial intelligence. Responsible AI is an area which is being well studied, well researched, because there are situations where people were being excluded or people were being targeted. A very simple example, at times when your accent is like mine, the model doesn't understand what I'm talking about. And then when the text gets generated, the text may from my speech, when a text gets generated, the generated text may send a wrong message to the fluent speakers of English, or if we train a model for Amharic or Afan Oromo or any other language in Ethiopia, and some non-native speaker is using that model, and then just we are generating a corresponding text, we may end up generating a message that would be inappropriate to the culture, to the people, or to the fluent speakers of that particular language. And if that's the case, you shouldn't have to do or enable the model to do that. If that's if it creates a negative or if it has a negative consequence on a particular society or community, right? So one particular example is, I'm not understanding kind of people of different races, right? People of different color, and not only in different scenarios, and people economically like people with low economic standing, right? So these kind of scenarios could happen, and if that's the case, if you realize that that's going to be the situation, you should be you should avoid or watch your machine learning model. Now, this is the most common process or framework that has been under use for the last 20 years, even more than that. And it's called a cross industry standard process for data mining. And this is the most commonly used process or framework for machine learning practices. And the first thing, before trying to create a model or searching for data, is understanding what business are you trying to use that model in, what kind of problem you have. Understanding the problem, understanding the business is the first thing that you should be doing. And next, you try to identify whether or not you have the right data and for whatever machine learning process or data science process that you are after. And in this case, once you identify the data sources, you have to understand the data and also prepare the data. And then you choose one or more algorithms, and then using the data, you can train a model or multiple versions of a model, and you evaluate. So this is an iterative process. During your evaluation, your model may suck, may not do what you wanted it to do, or you may have difficulty of answering the problem, the business problem that you identified during your business understanding. And if that's the case, you have to refine the business problem, and also just identify the right data source and understand the data. So this is a kind of iterative process. Between evaluation and business understanding, you may have this. And even when you try to understand the data that you would be using for training a model, you may not understand, or you may not get the right data to answer the right business problem. So this is a required iteration. And one thing from my personal experience at Microsoft, people assume that here, people assume that we have like data scientists can understand each and everything. That's not the true. And the other thinking is, every software engineering process is identical, right? So that is something that you should be very careful. Trying to fit a totally different process into a process that you already know. Machine learning, machine learning processing and practice is completely different, and has got this kind of framework that you need to apply. Asking more question is not a sign of weakness. Asking more question is not a sign of not understanding, but just a sign of willingness to understand, or to properly understand the problem. And doing things in an iterative way, especially, for example, between preparing data and training a model, is a way of refining your trained model to make the model a well-performing model, so that it addresses the business problem that you define at the beginning. And once you identify the model that you are satisfied with, and then just you evaluate according to the metrics that you created during the business understanding. And once you are satisfied with the evaluation process, and then the machine learning model addresses or answers the business problem with the expected performance metrics defined during business understanding, then just you go and deploy the model. So this is how it goes. Although there is no line between deployment and business understanding, I noticed a glitch. Although there is no line between deployment and business understanding, at times you may have to start a new process. But after deploying your model, you would have to also refine the process, because a deployed model might need to be refined. A model that was trained and deployed 6 months ago may not perform well after 6 months or after a year. So just this process can be repeated all over again, either for a new for training a new model, or for retraining an existing model, because there is a concept called the data drift. The data changes, the behavior of the data changes, and the model that was trained using similar data in the past have to be trained again to understand the current state of data. Now, the process is preparing data and training the model, and the evaluation. So in data preparation, you have handling missing data, handling outliers, handling imbalances, and scaling, feature engineering, selecting features. All these steps, we will be using a practical data points to train, practically see how we do things. Now, today's session is more of an introductory session of everything that we will be covering practically in the subsequent weeks. And the model training involves choosing the right algorithm. You may be choosing a classification algorithm among which are the k-nearest neighbors, the naive Bayes, decision tree, random forest. So among the different algorithms, you would choose one for the classification, depending upon the type of problem that you're dealing with. Or if you may be interested to create a regression model. And for regression, we have linear regression, logistic regression, support vector regression, and all kinds of different regression approaches and algorithms. And we may be interested in unsupervised machine learning, which is clustering. We may use k-means, k-means plus plus, or hierarchical clustering, or spectral clustering. And on another unsupervised model algorithms, we may be interested to dimensionality reduction, the PCA, principal component analysis, and the t-distributed stochastic neighbor embedding. Each of these, we will see at least one example from each of these algorithms. And during model training, we have we can choose algorithms depending upon the type of problem that we want to solve. And then we evaluate the model. Just when evaluating the model, we could use different types of metrics. For classification, we could use accuracy, precision, recall, or for regression, we could use a root mean square error or mean absolute error. Or for clustering, we could use silhouette score, and different types of metrics are there for each of the different models that we trained during the model training process to be evaluated depending upon the business problem that we are after to solve. And another thing we have here is the Microsoft team data science process. So a couple of slides ago, this was our framework. This framework has been there, as I said earlier, for more than 2 decades. But Microsoft built its own framework for software development focused industries. So machine learning, the artificial intelligence, data science, data mining can be done using this CRISP DM process. The CRISP DM process doesn't distinguish who does what, especially like just there are different disciplines in the software industry. Different people are have expertise in different areas. For example, for data understanding, you may not need a data science knowledge, right? For preparing data, you may not need a data science knowledge. But when it comes to model training, you would need to train to understand the different the characteristics of algorithm, or you may be required to write your own new algorithm, right? So that would require data science in machine learning and artificial intelligence knowledge, and even for evaluation. As a result of that, what Microsoft did is it's this segregated people as experts. For example, you have solution architects, project managers, data engineers, data scientists, application developers, and project leads. So after identifying these different disciplines, the process, as you can see here in this table, is, I don't know how I can, I'm sorry. So at different stages of the development process, we have different requirements. If every individual has got a role in different phases. in business understanding or data acquisition and understanding or modeling or deployment. At different states, different people have got their own role, and just this is nothing but matching or matching individuals in a task-based life cycle aligned with other processes. Now, the course resources, we have course resources, and then just I will explain what's going to happen in the next subsequent weeks. So let me know if there is any question here. I suggest instead of unmuting yourself, write down. I will watch for the next 10 minutes on the chat, and I will answer your questions. Okay. Thank you. Thanks so much, Cherry, for organizing the 2 questions for me right here. And what is your opinion on the use of machine learning in the stock market? Do you think it has been successful given the recent drop in the value of BTC and Luna? Can we conclude that the predictions made by machine learning were accurate? What does BTC mean? BTC, can you write down? I don't want to assume that I understood. I don't want to. Oh, Bitcoin. Okay. Bitcoin. Well, so I can answer this. Kibrav, the second question from Kibrav, when training the machine learning model, both training and testing accuracy is increasing, but there is a high gap between train and test accuracy. That is, training accuracy is much higher than testing accuracy. How to report the final result? I mean, cutting point for the final result. Yes. Okay. I will explain these two. The first thing is what's my opinion on the use of machine learning in the stock market. Is currently being used. So it doesn't need our opinion. Just the market is driven by using machine learning models, but models by themselves don't provide the full picture of what's happening, because most of the time markets, especially the stock market, is driven by people's action. People maybe the model may have just one of the inputs, one of the values that models watch in the stock market are the volume of trading. Trading means selling or buying stocks, right? That is one attribute, and that each of the attributes in the stock market have got their own corresponding weight. And the other weight for stock market is if there is any merger that's happening around a particular symbol or the particular company, or the other attributes, or the other factor is what are people saying on, especially just on the social media, what are people saying about the services and products that are being provided by that particular company, which is based on the sentiment analysis of people. And not only that, but also what are the news? What is there any news about this particular company? Is there any legal issues associated to this particular company in the market? So, and is there any change in the organizational structure? has the CEO of the company changed, right? Or one of the key players in the company has got a certain issue, right? Or said something bad. So everything contributes to the stock market, right? Of a particular. So all these are taken into account. More importantly, people's perception. The 2008 market crash was related to people's people's perception, the psychological state contributed to that. So a market crash can happen with this or that. And the machine learning models don't understand things that they are not trained with. If a new situation happens with an existing machine learning does not know about, then the model tells you a wrong answer to the right question. By the time you understand that just the model was wrong, it could be too late to fix issues. So that's part of the reason that I said, for example, here in the process, here in this process, once a model is deployed, there could be a change in data. There could be a change in the environment. So your model may be right for up until a certain point, but could be wrong. So when those kind of things happen, a machine learning model cannot properly predict the market. So that's a gap. So because of that, models have to be retrained again and again. And in relation to the testing, when training, I see people are having, in relation to, so here, when training the model, both training and testing. So this Kubra Ab's question, the second question here, I think, how can I bring this? Or you can see your chat window. I don't want to share here. So, but when training the machine learning model, both training and testing accuracy. Yes, training and there is a training and then testing accuracy. But the most important is the combined accuracy of the model. The combined. If the model performs so well during training and so weak during testing, don't use that model, because the model is overfitting or just learning more about the training data, and just if it's not performing well on the testing, that's a good indication that it's not going to perform well on a new data, because we will see in a practical scenario when we use actual data. So is in the algorithm how the learned pattern is represented. Learned pattern in algorithms are represented using different approaches. So algorithms are trained using either we can simply say using weight. So how we interpret weight in algorithm, it depends on the type of algorithm that we use to train a particular model. Weight, for example, in linear regression, weight could be interpreted as let me use white word here. Okay. Let's see. Okay, so for example, for linear regression, the model could be beta naught plus beta 1x. So the weight of a model means understanding what the intersection point and what the slope is. So our ultimate objective is understanding, calculating this. And this is how we will be determining the pattern and how we determine how the pattern is represented. Depending upon the different types of model, we would see weight represented in different ways. And okay. Okay. In multi-class classification problem, after we train our model, we plot a confusion matrix. From the confusion matrix, we calculate an accuracy of the model. But is this accuracy result training result or test result? That's a testing result, in short. I am confused, please tell. It's usually like just the confusion matrix is based on a test data for classification. Can you share us the slides, please? Yes, I will. In question, one of the problems of model development using machine learning is model overfitting. What are the strategies to solve or minimize this problem? To do that, fine-tuning your model, and most of the time, including as much data as possible, and trying to use a cross-validation technique. And the other question is, as you mentioned at the very beginning of the discussion about the impact of machine learning, what are the positive and negative impacts of machine learning? Second, both data mining and machine learning use the same models. What is the difference between data mining and machine learning? Machine learning is, just to start from the second question, machine learning is the superset. Machine learning is not only data mining. Data mining is somehow focused in a specific area to identify pattern. And data mining, in most cases, is unsupervised machine learning approach. But machine learning has the supervised approach where you train classification models and reinforcement learning, where you train models that can be used for robots. So that's the answer. And the other question is, during dimensionality reduction, is there a risk of losing important features that are representative of the data? If there is, how can we handle that? Yes, there is a possibility of losing important feature, but the ultimate objective is not utilizing that data, but just to understand more about the data. The purpose of dimensionality reduction is not to maintain the important features, but to distinguish between among the features which are the important, between features which are the important features, not within a feature. So that should be realized. And can you share? Okay, I do. So if deep learning use artificial neural network, what does normal machine learning uses? So deep learning uses artificial neural network, and machine learning has got different approach. For example, logistic regression doesn't use. So the linear model, the linear regression uses a mathematical representation, a probabilistic calculations. Like some of the classification use naive Bayes probabilistic based approach. So that's how some of the machine learning models utilize. But in deep learning, you represent learning just like humans learning ability based on neurons, which we will briefly touch at the end of this course. And how do you evaluate the performance of a machine learning model, and how what metrics are commonly used? We will discuss about this. We have different metrics. I mentioned some of them, but we have dedicated chapters, dedicated sections for this. And how do we choose a machine learning model, a machine learning algorithm to predict an outcome? And how do we know which algorithms are appropriate? Excellent, very good question. I will show you a cheat sheet of algorithms. What kind of algorithm that you should be using for what kind of problem. And I will show you there is a mapping between problem to algorithm mapping among the different types of algorithms that we can use in different machine learning frameworks. And the second question here is, when will we use principal component analysis for feature selection? We will see in an example. So when we use principal component analysis. And I think you have more questions. Probably like I will have to save and address each of them as we proceed in the program. I still see people. Okay, since I know just some of you are going out and coming in, either due to a network issue or because you may have some other important things, but the thing that I will be discussing after this time is important, so I suggest you stay because I will be summarizing some of the course outlines and important things that we would be doing in the next subsequent, weeks. Okay, the first one is the machine learning. The email that I sent earlier today, which is so. Can someone ping me if you see the email that I shared here? Yes or no in a chat. Can you see? Okay, good. Okay, perfect. So this is an important thing. Perfect. Thank you. One is enough. Yes, you can see. All of you can see. Thank you. Please go through this outline, but I will briefly go through that. And for our machine learning process, we would be using one of these environments. You may be required to use your local Python environment, which would require installing Anaconda with Jupyter and the required Python package, depending upon the type of machine learning that we would be doing. There are thousands of packages that are developed for different purposes, and especially in machine learning, we have popular frameworks that we would be using. So a local environment would be set up. You may just especially if you cannot stay on the internet for long, I suggest you depending because of like just a cost and availability. If you have to study at home, not using your university connection, setting up your local environment on your laptop or your desktop would be important. And for doing that, I suggest you following these two steps. These are the two references. And the other one is if you can stay on the internet, then there are three different options. There is a cloud account that you can set up from Anaconda. and there is a link here that you can follow and set up Anaconda Cloud environment for yourself. But I will generally talk about the all of them, what makes them identical. In the Google Colab cloud environment, this is my favorite environment because it enables you to utilize an environment which is super expensive, especially for graphical processing units. If you have to have a laptop with GPU or graphical processing units, you have to pay so much. So that requires an extra additional money that you have to pay for your laptop to have a GPU. But Google is providing that free of charge for you. The only thing that you would need is an internet connection and a Gmail account. If you have a Gmail account and in a Google an internet connection, you can have very powerful things. And the other one is CodeSpace from Microsoft. CodeSpace, Microsoft is also providing a virtual machine, a server. So all these are dedicated servers for you. And GitHub, you need a GitHub account for that. And then just you can follow the CodeSpace from here. So this is in relation to an environment that we would need to set up and just try each of these. And the other thing is in relation to books that we would be using. The two most frequently used resources or references for our training are going to be these two books. This is like, just remember, this book, which is available here. Let me show you what it looks like. So this is what it looks like. So this is dive into deep learning. And whenever you get a chance, if you want to read offline, you can download the course. And I say just look where my cursor is. The PyTorch is the one that I recommend because it uses the PyTorch framework, and we will reference some of the contents in this book. Everything that you see here, all these sections are available here in the PyTorch PDF. The reason why I couldn't send you is this book is close to 1,000 page and about 39 megabyte. I could share from my Google Drive, but I cannot send you through email because it exceeds the message limit. So this is one of the popular books. By the way, look at this. This book is used or adopted at 400 universities across 60 countries. So why don't we make ourselves as 6 of the universities to this? So this is part of my experience when I was in Ethiopia as a student. Some of my teachers were teaching us courses and expecting us to do exercises from Harvard University and other popular universities and telling us, oh, you are as good as a student in Harvard. So we can be as good as any of those students in these 400 universities in 60 countries. So we can, these 6 universities can adapt this, and then we can create our own resource. So this is one thing. And the other book that we will be using is Python Data Science Handbook. Again, this book is here, Python Data Science Handbook, and we have the corresponding code. The code links are provided for both books, both the source, the content of the book and the GitHub code. So go through this and familiarize yourself. And we will be going through the chapters, and mainly from the second book. From the second book, we will be using. Let me go through the second book here. In this second book, if you see, not the first section, but introduction to NumPy, an important aspect, multiplication with pandas, visualization with matplotlib. The second, the third, and the fourth chapters are going to be our focus. And finally, some of the topics in machine learning, we will take a closer look here. And we will furnish many of our contents from details that are provided in here. Not only these tables, but also the details that we have here in the course outline. The course outline has got other references. Books with code in the GitHub. Although we may not get like just a full code, but also the full book, we can use the code written for these books. The code is freely available at GitHub. So using GitHub and making GitHub your friend is an important thing for you to be successful in this course. And yeah, and here, I hope many of you have gone through the outline, and if there is any question, write me an email and I will address them. Just to say, just to basically repeat one thing from our initial discussion, please don't forget, when you are sending an email, when you are sending any email, please add sharp bracket, FML sharp bracket. This means the foundations of machine learning. And why am I doing? If you guys are not using Outlook, I have an Outlook here. As you can see, I have many accounts, but I am using this account for your email communication, and probably many of you have already sent me email here, right? So these are the emails that I receive, and because I have a rule here, all your emails land in this particular folder. So this is why I ask you to include these in your subject so that you will get a focused view. And if you have any question, send me email to djambari@extremeiq.com. And extremeiq.com is my own website, which is a registered company here in the state of Washington. Although I'm not doing much with the company, I use this email address and its branding for any training communications. If there is any question, let me know. Somebody said, I haven't received this email. If you are here not registered, then you won't get anything. I'll be communicating to people who are registered on using the form that I sent. So just to show you how it happens, I see all of you here. So the registration is, there are 203 people registered. It's okay. I was expecting about 195 people, close to 200, but we have about 203 people here, and I will be communicating only to these people. And every attendance is recorded here, and just your availability And since we are going to provide certificates to attendees, we will be watching this detail closely. So just from attendance perspective, we will see who is attended, who hasn't attended. And so any question you can text to the chat. Unfortunately, there seems to be Abu. You may have a question. Can you try talking? Oh, excellent. That's a very good question. A lot of business problem, but getting data set for the problem is not easy. So how to overcome? So I think just yes, I understand. At times we will discuss about these as an advanced topic. Sometimes you may not need as big of a data as you would need. There is a concept called an approach in machine learning called transfer learning. So using transfer learning, we can enable ourselves to train useful models. But if there is no data at all, there is no machine learning approach that you can use. And please show you our list to check whether we are. I'm sorry, that's not possible. If you are receiving email, you are registered. If you are not, you are not registered. That's how you can see. I cannot show you everybody's list. Dr. Achenov, you may write on the chat.
Yeah,
I see your hand raised. Yeah.
Can I speak? Okay. Thank you for your nice presentation. Really, I'm very appreciated those attendees was joining us. They will continue till the 9th week. Maybe as we have discussed last time, you have planned to have a kind of rewarding. Maybe it is good to inform early to have a good competition about that reward, just as a reminder to you. Thank you.
Excellent. Thank you so much, Dr. Achenov. Yes, we discussed about some reward as part of this. There is going to be, you will be choosing a business problem in your area of expertise or in your field of specialization. And our ultimate objective here is to provide service to you. My purpose here is providing service to you, and through you, since all of you are Ethiopians, I think I am serving my country, Ethiopia, and that shouldn't be the end of it. One, you will be serving others exactly the same way as I am doing to you, and you would extrapolate this service habit. And second, we shouldn't stop right there just by simply learning what I am teaching. Instead, how about we try to solve a problem in Ethiopia by using the topics that are being covered, that are going to be covered throughout this course. And with the coordinators, I will be discussing about the type of reward, but a very exciting reward is going to be presented to you. Very exciting, depending upon your choice, or we will discuss, right? There is going to be a reward. There is going to be a reward for everybody. I mean, not everybody, for projects, machine learning related projects that would be identified, that would be ranked as the first top 3, rank 1, 2, and 3. I brought the idea with university coordinators, but what I thought is not yet decided, but I am thinking a sizable reward to the top 3 project ideas and solutions that they solve, or the type of problem that they solve in Ethiopia. An Ethiopian problem solved by machine learning project, top 3 projects will be rewarded. That's the level of detail that I can offer you, but just the specific requirement, we will be documenting with the coordinators, and we'll be communicating that to you. But just get yourself ready. Thank you, Dr. Archana. Any other question? Okay, how large a sample should be to conduct machine learning, or is there any cutoff point for a sample below which, well, so I think just let's discuss on, this is on type of algorithm and problem basis. If you are going to work on a deep learning, you would need a huge data, a big, very big and complex data. If you are not, if you are using, for example, regression, linear regression, you may not need as much data as you would need in other areas. So it's dependent on the type of algorithm that you're training, the type of problem that you're trying to solve. So we cannot say, we cannot have a blanket solution with regards to the size of data that's needed for machine learning model training. Any other question? Okay. 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 Is your presentation classification as supervised and clustering as unsupervised? Do you mean we cannot have unsupervised classification approach? When we say classification, that means we are classifying to known labels. So if we are classifying to known labels, there is no unsupervised classification. Okay, more questions would come, but so remember to review these details, and we will start digging we are going to get deeper into the sections as of next week. Which approach is more preferred for health-related problem, machine learning or deep learning? Due to lowering the error rates? Yes, I think just this is a very good question. For health, in healthcare, it depends on the type of problem again. In healthcare, you may be predicting something that doesn't have impact on patients' outcome. In that case, depending upon the type of data, your data determines what kind of model that you can train. If you have more image-based, more complex features that you in the data, then deep learning is the most preferred one. For example, like just scans. For scans may have different attributes. Image-based medical data, right? And for that, you would use deep learning. But for others, you would use non-deep learning. Actually, deep learning is a machine learning type. So we cannot say between machine learning and deep learning, but we can say deep learning and other type of learning in machine learning, right? That's what I would say. Depending upon the type of data, you would choose either machine learning or a non-machine, either deep learning or non-deep learning approach. So the type of data that you have at hand determines. And based on the data, if you can get, reliable performance from a non-deep learning model, why not you use that model than just struggling to get a deep learning based model training. So that's something that I would say. The difference between machine learning and statistical learning, please. Yes, we will be discussing about this, but just to say what's the difference between statistical learning and machine learning, the main difference learning in machine learning is statistical learning focuses on based on a sample data you want to estimate to a population, and that estimation that you would have for from a sample to a population involves a certain level of uncertainty, right? Uncertainty with plus or minus this rate of uncertainty. We are saying XYZ. So this is what a statistical learning or a statistical model is. Just for example, like linear regression is in both in statistical learning and statistical learning and machine learning. When it is used for machine learning, you use it for prediction. When it is used for statistical learning, you use it for estimation. So this is the difference between machine learning and statistical learning. Okay, I understand from University of Gondar there is some internet connection issue. Yes, I will share the recording of this session and also the slides so that you can get up to speed. And data mining versus machine learning, I mentioned that earlier. Data mining is a subset in a machine learning. Data mining is more focused on identifying hidden patterns in data, hidden patterns in the data. Machine learning is a broader, so all the other algorithms, non-data mining related algorithms cover machine learning. So that's a difference. Okay. Data science versus machine learning. Please watch the taxonomy that I'll be sending on the data science and machine learning. So machine learning or data. Okay. Any other question? Okay. Okay. Yeah. Thank you. How much data is appropriate for data mining? I think I answered that question. Probably it may not be heard by most of you, but I answered how much data. Okay, what's the importance of machine learning in groundwater potential investigation, and how does it differ from the statistical approach? As I said, the statistical approaches are for estimation, but machine learning approaches are for prediction. That's the difference. And in ground water potential investigation, I would have to look it up. I cannot upfront answer for this particular area, but I have to look it up. Send me an email, please. Jonas Oida, please send me an email about your question, because I'm interested to know about the application of machine learning for groundwater potential investigation. What is the approach to handle overfitting, cross-validation or bootstrapping? Cross-validation is just a good approach. Bootstrapping, you could use bootstrapping even with cross-validation, but cross-validation enables you to split your training data into multiple folders and then just training your model k times using the k-1 data and keeping k for validation. So that's a good approach, so that the model doesn't rehearse, doesn't recite the data. Could you clarify reinforcement learning? Reinforcement learning we will discuss when we get there. We cannot finish everything in one class, so this is a beginning. Okay. Okay. So thank you very much for joining me, especially those of you who stayed within the class despite the different challenge that you were having. Thank you so much. Thank you.
Thank you too.
Thank you a lot.
ይሰራል አይሰራም? አይሰራም። ይሰራል አይሰራም? አይሰራም። አይፈራም ገም አይፈራም። አይሰራም ገም አይሰራም። አይፈራም ሳሜ ነው።
You guys are not wanting to go out. Hello guys, how are you? Hello. Hello.